PureVid's HQ, and this section is talking about imaginary and complex numbers. So let's say we got the equation, a quadratic equation such as x squared minus 10x plus 34 equals 0. And we want to go solve this quadratic equation. So this isn't going to factor, so we're going to want to use the quadratic formula. So to do that, we're going to have x equals, and then it's going to be negative b, which here would just be positive 10, plus or minus the square root of b squared, which is going to be 100, minus 4 times a here, which is 1, and times c, which is 34. And then we're going to put that all over 2a, which in this case is just 2. Now then, if we go and simplify this, we're going to get x equals positive 10 plus or minus the square root of negative 36 over 2. So here's where we run into the problem, because we have a negative sign under a radical. And so what this really means is the root negative 36 means a number which when squared gives negative 36 for the answer. But that's not possible because any real number when it's squared is going to be non-negative. So that means that root negative 36 isn't a real number. But instead of just giving up, mathematicians went ahead and invented a new kind of number for this, which they called imaginary. So the first step to do that really is to define like what an imaginary number is. So really what the imaginary number I is going to be a number whose square equals negative 1. So that means that I squared equals negative 1, or I equals root negative 1. So that means that the number root negative 36, that can be rewritten as the square root of negative 1 times 36. And now we can distribute this radical over multiplication. We know that the square root of negative 1 is just I, and the square root of 36 is 6. So we're going to call this 6i. So now that we can go back to this definition, and you can use this definition to go back to this problem to now solve this. So we now know that x is going to equal 10 plus or minus 6i over 2, or x equals 5 plus or minus 3i. So the solutions to that equation, 5 plus 3i and 5 minus 3i, we call complex numbers. Now a complex number is going to have a real part and an imaginary part. So basically a complex number is going to be in the form of a plus bi, where a is the real part and b is the imaginary part, and I is just the square root of negative 1. So now that we have these complex numbers with a real part and an imaginary part, we can look at how they fit together graphically. So basically the way you want to do that is we're going to graph it on a scale which kind of looks like a Cartesian system, but basically this horizontal axis we call the real part. Hang on. So this will be the real part, and this vertical axis we call the imaginary part. So 5 plus 3i, we would graph by counting 5 to the positive 5 on the real axis. We go 1, 2, 3, 4, 5, then positive 3 on the imaginary. 1, 2, 3. This is going to be about here. Whereas 5 minus 3i would be down here. 1, negative 2, negative 3. So this original problem, which we had x squared minus 10x plus 34 equals 0, we found that x was equal to 5 plus 3i and 5 minus 3i. Another cool thing about this is we can actually check this now by plugging in these solutions and seeing that the equation is true. So let's just go with 5 minus 3i. We're going to check that. So substituting that in for x, we're going to go 5. What is going on? Sorry about that. Pen malfunctioned. 5 minus 3i squared minus 10 times 5 minus 3i plus 34. So first thing we need to do is just square this out. That's kind of like just squaring the binomial. So that's going to get us, we're going to first square the first term, which is 25. Then negative 3i times 5 is going to be negative 15i, and then doubling that, we're going to go with negative 30i. And then squaring negative 3i just gets us positive 9i squared. Then we're just going to distribute in the negative 10 here, and we'll get negative 50. Then right here we'll get positive 30i. And then we got the plus 34. So then now the next thing we're gonna want to do is just combine like terms, and to do that, let's see, we have a 9i squared right here. That's the only term, so we're just gonna put 9i squared. And then we have 25 minus 50 plus 34, and that's just gonna end up being positive 9. And then we have negative 30i, positive 30i, so those are going to cancel. Now, remember that I equals the square root of negative 1, so I squared equals negative 1. So that means that 9 times I squared is the same thing as negative 9. So now we have negative 9 plus 9 equals 0. So that shows that this solution is valid.